Hey everyone, welcome to my problem solving in Python tutorial for beginners. First and foremost, I want to set the expectation that you do know how to program in Python at least a little bit. This series is not meant for someone who needs to learn Python from scratch. I will find a good series for that, post it in the comment, and you can come back. This series of tutorials is supposed to help you think about programming in a slightly different way. When you're given a problem, when you're given inputs and you're given what an output needs to be, how do you take that from basically the input to the output? So when you're given a task, how can you think about that task in a programmatic way and implement a solution? So I'm going to be using the website CodeWars. I love this website. It's got tons of problems, and I am going to only do problems that I myself have not seen before. And what's really nice about this website is that you start from basically level 0, and as you solve more problems, you level up. So I'm going to split this up, probably a couple problems per episode in the beginning, and as the problems become more difficult, I am going to reduce the amount of problems per episode. So let's start here. We're gonna jump right in and start doing rank up challenges. I've also got Google Colab open, and if you haven't heard of this before, it's a free thing Google provides. It's meant for machine learning, but it's a notebooking tool, and they give you a GPU for free, actually. So if you want to do training of machine learning algorithms, you can use this. But I'm just going to be using this for notebooking purposes. And if you haven't heard of notebooking before, it's very simple, it's really intuitive, and it's really just a nice way of writing code and seeing the results immediately. You'll get what I mean when we start doing this. So let's jump right in and start training. Write a function that accepts an array of 10 integers between 0 and 9 that returns a string of those numbers in the form of a phone number. So they're going to give us 10 of these, and we have to format this in this phone number way. And this is US phone number formatting for any foreigners out there. And so here's the instructions. They usually give you an example, and then they give you some hints down below the example. Down here you can see they have some tests. So you can actually see the inputs they're going to send through and the expected output. And then the actual challenge, you run it when you hit attempt. They do not tell you what the inputs and the expected outputs are for the attempt. There's generally tons more tests that they've run. So I have had it many times where I write code that works for everything in here, and then I'll attempt it and it breaks for one of them. And really, when that happens, then you have to start, like, it's a different type of problem solving. We'll get there, I'm sure, because I'm not perfect. So this is a string formatting problem. We're given an array. Now, one thing you may or may not know is that a string in and of itself is an array of characters, and actually you can treat it as an array. So what we're going to do is copy this function here, and the first thing I'm thinking about is, how do I loop through each of these and then basically build up a string depending on where we are. So because the input is always a constant length, we can actually write some code that is it's less general than it could be. So we want the first 3 numbers of this array to be within some parentheses. What we can actually do is break this up into the different portions here and then combine them all together. So we'll say part 1 is going to equal f, and now if you're not aware of this, if you put an f before a string, it actually lets you do some really cool string templating. So you can do things like this. So first of all, I'm going to add the parentheses here, and then if you add in curly braces, you can actually execute code that when returned just gets input into the string. So actually, as a really quick example here, let me show you what I mean. So if I do f1 plus 2 here and I run this, see, it returns the string 3. It's executing the code in here. Executing code. And if you take away the braces, it just becomes a normal string again. So this is a nice, so, you know, you'll see a lot of people will do the whole, give me a string and then do the whole percent variable list. I don't even know how to do that because this is just far simpler. So we need the first three numbers to be in here. And what this is gonna do now is, let's just return part 1 just to start, okay? Let's pass in an array of 3 numbers, and you can see, boop, 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 boop. Forgot the 1 there. 1, 2, 3. So you can see here's a piece of code being executed. I'm accessing the 0th number, then the 1th number, then the second, first, second, all in parentheses. Part 2 of this phone number is just gonna be the normal list. Normal. Just numbers side by side like this. So just to make things a little bit quicker. Now, I know you're probably sitting here being like, yo, this is really potentially inefficient, or just like you're solving the problem too directly. Well, I'll tell you what, you have to take every problem differently. And if a problem requires something general, build something general. If you can get away with building something pretty straightforward, then you know, do that. I mean, really, it just lets you finish things a little bit quicker. So now we've got the 3 parts of the phone number, and yeah, I could have done this in all one big string, but you know, who wants to do that? It would be very long line of code. So now we just need to, let me close the string. We just need to put all these parts together. Part 3. And of course I need to actually bring in a phone number length array. And there you go, phone number formatting. So here's the code, copy paste it back in there. Give it a test. All these tests pass. Let's give it an attempt. You can see all these attempts passed, and then you can submit. And that's basically just submitting the problem or the solution to CodeWars, and they'll accept it, and you know, you'll move on. Alright, so I went on to the next one, and here we go. Write a function that takes an integer as an input, so like a whole number, and returns the number of bits that are equal to 1 in the binary representation of that number. And they're going to give us a positive input. So the binary representation of 1, 2, 3, 4 is this, and then basically what they're doing is adding up all the ones. So 1, 2, 3, 4, 5. Converting things to binary, many ways to do it. You don't need to build something from scratch. Computers speak in binary, so there's always lots of different things going on. I believe one good way of doing it is like this, where if you call this bin function, which stands for binary, and you pass in a number, it will spit out like this. And in this case, it's a string, where 0b, and then the number itself. 0b tells us it's a binary number. And this is actually like a valid thing. Whoops. This is like a valid like line of code here, 0b, that tells you what it is. If you change that to x, all of a sudden it becomes hexadecimal. So that's just a little thing on binary. And if we wrap this in a string. This is a great way to bring something to a string, is just wrap it with the string there. We get the actual string back. Now, what we need to do is chop off this 0b. So if we have an array 1, 2, 3, 4, 5, and you wanted to chop off the first number, what you can do is use this cool little syntax where you, and just to make it very clear, I will do it this. Start 1 and let's say 4. And the syntax is after an array, and I'll make it really, really clear so you know that this isn't some weird thing here. After an array, you can do the indexer, right? And if you, like for instance, if you're just going to do 1, it's going to return the second item because 0 is the first one. You can also slice it, get a range. And the way you can do that, so again, start is 1, so it's going to return 2 again. If you put a colon in here and you add another number, you can get start to end. So it goes all the way up 0, 1, 2, 3, 4, and 4 is not included as the index. So if I do 5, that will give us all of the numbers after 1. Now, if you know that you need to go, if you know you want all the numbers except for an amount on the left, you can actually go ahead and exclude the end number, and it knows to just give you the whole list. So because strings are just arrays, we can use this slicing syntax, and we want to get everything after and including index 2. So we type in 2, and we can omit the ending number, and Python interprets that as just give me the rest. And the same is true for the other side. If I wanted everything before the D, I could omit the first number, and it's going to return that as well. So if we do this, we get the binary number. Now, the next thing we're going to do is use a tool called list comprehension. And this is a really nice tool Python provides. Let's say we had a list of numbers. 1, 2, 3, 4, 5. And we want to double each number in this list. So the non-list comprehensive way to do that would be to loop through every item in the list, right? So if you're not familiar with looping, you can do it like this, and you can say it's going to loop and through every item in the list, print it out. We can have a list B that is empty, and then we can append that element times 2, and then list B, whoops, list B now contains the double of everything in list A. So this is a little wordy. So what Python did is they added this thing called list comprehension, which I haven't seen it in any other language. And this is one of the, there's so many reasons Python's great. So here's the syntax for list comprehension. You have it in square brackets, and then you have the list you are looping through, and then you have this syntax, which looks very similar, right? We just did something like this, where, so you can see the output there. This is shorthand for basically this, if you treat the result as a new, thing, if we set it something equal to something else. So you're looping through A in list A, and then here, before the for, this is your opportunity to modify each element. And if we want to modify each element by multiplying it by 2, you can see we can do that here. So you can think of this operation on each element for that element in the list. And this is where you're defining the variable that represents each element. So in this case, this would also multiply by 2. So we want to do a times 2 for a in list A. So we want to do for each a in list A, for each element in list A, what we want to do is multiply that element by 2, add it to a new array, and then return that array. Great. Back to our original problem. We now have the string representation of the bits, okay? And what we want to do is turn each of these string bit numbers into an integer. And we are going to do that with the list comprehension. And we can treat this as the binary representation. We'll set that to a variable. Binary representation is going to be equal to this. And whoops, copy that. For, we'll call it B. We'll just do bit in binary representation. And what do we want for each bit? We want to turn it into an integer. So we will wrap it with the int function, which will turn that into an integer. Remember, this is actually just a string. It's going to loop through. And what this is going to do is return because remember, a string's an array, right? It's going to return each letter, you could say, as an integer. So we get 1, 0, 0, 1, 0, 1, 1. And that will be equal to what was the string representation of this, or equivalent to it. Now we can use one of Python's awesome built-in functions called sum, which will take every element of the array, add them all together, and this gives us the answer. So we can keep this as a variable here. We could technically, it would actually be quicker. I wanted to have this variable here just to separate a little bit context, but we can actually just go ahead and plop that right in there. Make this a good old one-liner. And now our count bit functions are right here. And remember, we had hard-coded the number we were working with. We're going to replace that with n. We have to make sure that we now return this value. We're going to test it. We passed all the tests. We're going to attempt the run, and we passed all of the tests in the attempt. We're going to submit that problem and move on. An isogram is a word that has no repeating letters, consecutive or non-consecutive. Implement a function that determines whether a string that contains only letters is an isogram. Assume the empty string is an isogram. Ignore letter case. Great. So what they are asking us for is to build a function that detects if each letter is unique in a word. So you can see here, each letter only appears once. So this is true. This is false because A is here twice. And this is false because O is here twice, so they don't care about caps. Okay, how am I thinking about this? Well, one of the first things we have to do is clean the input. And we need to make sure that the input is ready for use immediately. And one thing they want us to do is ignore case. We can't do anything until we remove capital letters, because one aspect of programming is that a capital letter is not equal to its lowercase version. These are two separate things. You can see this is true, that was false. And that makes sense because they have different bit representations. Otherwise, how could a computer tell the difference between them? So we have this lower function here that we can call on a string to make everything in it lowercase. And if we call .lower, you can see it returns the lowercase version. So getting the lowercase version of this input is the first thing we need to do. We can work with it at that point. So then the rules are, we need to figure out if there is a duplicate entry in this list. I have done a version of this problem. Basically, detecting duplicates is really what this problem is asking us to do. Are there any duplicates? If there are, we need to return false. If there are not, we need to return true. There is a very simple way of detecting duplicates in Python. So, lists can have duplicates. There is a data type that acts like a list but cannot have duplicates. And you can convert to it from an array. And it's called a set. A set can basically have items like an array, but it cannot have duplicate values. So when you convert an array to a set, like this, it returns back the set without duplicates. It's so similar to an array that you can even use the same functions like length on it. So a good way to detect if there's duplicates in an array is to compare the length of the array to the length of the set that you have converted that array to. And I don't even need to use Google Colab to do this. What I can do is set a variable called lowercase that we're going to call lower on, and we are going to return. Now, some people like to do something like this, and I'm about to teach you a life lesson on how to do something very simple. So we're going to call a variable called isogram. Initialize it as false. We're going to write an if statement to see if the lowercase string is an isogram. So, and then I'm going to show you how to basically shorten this whole process. But the one thing we have to do is do the actual comparison. So we'll do the length of the lowercase version of the string. If that is equal to the length of the set of the lowercase, remember, converting it to a set automatically removes duplicates. If they're equal, is isogram is true. And then you return is isogram. Well, you can basically short circuit this by returning this comparison directly. It may be tempting to do this pattern here just because you might want to define your variable. Like, you need to return a Boolean, so you'll initialize it as false and then do the true condition. It's much quicker to just return the logic that directly that gives the result. So, if the length of the lowercase version of the string is equal to the length of the set that we just converted to, it is an isogram, and we can test this. And just to be sure, the reason why this works is because since set removes the duplicate values, it gets shorter, right? If there's a duplicate, the length of that array of the set is shorter than the original array. And if they're not equal to each other, then there was a duplicate removed. So we're going to submit this. Well, I'm going to cut it there. And in the next episode, we will go through 3 more problems. And eventually they'll become so hard that we don't have enough time to do like 3, so we'll lower it to 1.